Yes, sir.
Part 2.
So, are we all supposed to? Because I randomly selected 5 of them. Did you guys? Do we all just use the same 5 then, so we can answer the questions together, or is it?
I say that's what we do, just so we're not all getting different answers.
Okay.
Sure.
So did everyone else already select them too?
Let me go through and do that. So which ones do you guys want to use? We can pick 5 and do it together?
Yeah. Ooh. Like I already picked 5. Did you guys already pick 5 as well? We can just all pick one from each of our picks.
That works.
We
just row.
just go down the side.
Whatever you guys want.
Yeah, you can just go down the side. That way it's there in order.
1, 6,
It would be easy to read.
Yeah.
We do a stratified sampling. 1, 6, 11, 16.
I like that.
See, Sister Kennelly, we learn. Okay. Is that cool if we do 1, 6, 11, 16, and 21?
Yeah.
Yeah, that sounds good.
Okay, 1, 6, 16, 21. All right. So then we just add all these together and get the mean.
Yep.
All right. Let me know when you guys get there.
I got 46,500.
Yep.
That's what we got.
What did you guys get?
46,000 or yeah, 46,500.
Ours is almost right smack dab in the middle.
Yep.
Okay. Ours is not unusual. It is right in the middle. It is true mean. Most common.
That is talent right there, guys.
Wow. Stratified. And they did say that that was a good method, right? See?
No.
Cool. So it is not unusual. It is usual. Okay, so then we're at D now. Compare your mean from question 7A to the means obtained by at least 3 other individuals. What do you notice? In practice, you only get to see the means from the samples you draw. You do not get to observe any other mean that could have occurred.
Does that mean we should have all gotten our own?
We could if you want. I'm sure that would be okay. Well, does someone want to keep that? And I'll just do 2, 7, 12, 17, and 22. And someone else can take 3, 8, 13, 18, 23. Someone do it like that?
I'll do column 4, so 4, 9, 14, 19, 24.
I'll do column 3.
Alright, I'll do 2.
If you guys are ready,
I'm ready.
fine.
I think I am too.
Let's column 4, it was 46,960. For column form, I got 46,960.
Can you guys hear me? Can you guys hear me?
Yeah.
Yeah, I can hear you. Can you hear me? Okay.
Sounds like a video game.
Yeah, I can hear you guys. Can you hear me?
Yes.
Yeah.
Okay.
Yeah, I can hear you.
There's about a 4 or 5 second delay now. Can you say, let me know when you can hear me?
I can hear you.
Hear me.
About 2.5 seconds. That's better. Okay, sorry about that. For some reason, my internet just freaked out. Okay, so you guys figured out for your columns, I guess?
Yeah.
Yeah.
So we have column 1, which was original at 46,500. What was in column 2? That was
48,860.
860. What was column 3?
Oh, sorry. Column 3 was 48,316.
Okay. And 4?
46,960.
Cool. And then, okay, and then the question is compare them. What do we notice?
They're all still roughly within.
Yeah.
Yeah, they're all pretty close together, especially
Yeah.
when we're looking at
Within 3,000.
at the spread. When we're looking at the spread, they're a little high, but they're all fairly close.
Yeah.
I don't think any of them are unusual. Okay. All right. So does that answer the question, I guess?
Yeah, I think so.
We get question 8. We have the Graduate Management Admission Test, the GMAT, is used as an admission criterion in many Masters of Business Administration programs. The scores on the GMAT are normally distributed with a mean of 529 and a standard deviation of 113. Okay. So mean of 529, standard deviation of 113. Okay. Consider a simple random sample, or n equals 10 students taking the GMAT. So our sample is of 10 students. N equals 10. Okay. What is the shape of the distribution of the sample means for all such samples?
The scores on the GMAT are normally distributed, which is the Trump rule, so it's normal, right?
Right.
Normal,
Correct.
yes. Normal. B, how do you know that the distribution of the sample mean has this shape?
If the sample mean is 529.
And the rule on that is?
It's the rules
If the population is normal, then the sample distribution will always be normally distributed. Okay. What is the, okay, C. What is the mean of the sampling distribution of sample mean scores for all such samples? That number is
Is it the 529?
over the square root of 10. right?
Well, I thought I wrote down in my notes.
Oh, that's for the standard deviation.
Yeah, the mean of the means equals that weird Greek U-looking thing that's equal to x bar.
Oh yeah, it's
Population mean, which is just mean.
yeah.
So
So it's
five-
529.
Yeah.
Okay. So D, though, would be 113 over the square root of 10, right?
Correct. Yeah, that's correct.
Okay.
Let me know what you got for that.
Let's see. Okay, so we've got one second, sorry. So I got 35.733.
Yes.
Yeah, that's what I got.
Yeah, what I got.
Or if we're able to always do 3 decimal places, it would be 35.734, I guess.
Yeah.
Yeah, when you're down.
Okay, so 35.734. Cool.
Awesome. That was a short one.
I agree. I mean, that was took a lot of fun.
Yeah, it's really taxing. We're such a good group.
Well, that's it. See, we work well together. We're efficient.
Yeah.
Down to.
We all love sleep. That's why.
That is right.
It's actually good that we start so late because it makes us stay on point. All right. Let's start the group quiz. Let's take a look at that.
Oh,
11. 9. We get the first 2 right. True. All right. Is everyone ready?
Yep.
oh, sorry. It logged me out, so I just had to log back on.
No, you're good.
Okay.
All right. Let me know when you're ready.
Okay, I'm almost there. Okay, I'm ready.
Okay. Number 3. When taking samples of n when n equals 5, what's the distribution of means histogram when the parent population is right screwed? Right screwed. Right screwed. Oh boy.
There we go.
Right skewed.
Is that skewed right
Yeah.
for the
Should
answer?
we use that applet?
Yeah, let me see.
Because on the lesson 7, let's see here, lesson 7, question 10, it's pretty much the exact same question. So it says a sample size n equals 4 are taken from right skewed on self data. What is the shape of this distribution? And the answer is right skewed.
Yeah, and I just plugged it into the histogram, and it's almost normal, but it is still right skewed. There's still just a little bit more information on the right, according to the histogram, or the sampling distribution applet.
And if we go by based on what was in the YouTube lecture, if things are greater than 30, then that's normal.
I felt like in that YouTube lecture that he was saying the same thing every time. And I even think I wrote it down the same way. I need to go back through my notes. I'm gonna go with skewed right. What do you guys think?
That's what I'm gonna say.
Yeah, that's what it looked like from the video.
Yeah, skewed right for sure. I would say that. When n equals 100, though, I just did that one. 100 reps, and it's fairly normal looking. You guys want to try something out?
That kind of goes with the rule, right?
Yeah, the more you do.
Something.
The larger the
The
group.
law of large numbers.
Yes.
That's what it is. That one.
I always get that one and the central limit theorem confused. Distribution means becomes okay, yeah.
So that I would say that it's normal.
I agree.
That's what I say.
Okay, so then 5, when taking samples of n equals 100, what is the shape of the distribution of means histogram when the parent population is normally distributed?
It'd still be normal, though, right? Because
Yeah,
normal trumps.
Mm-hmm. Yep. Okay. So 3 is right skewed or skewed right. 4 is normal. 5 is normal.
Yes, sir.
All right. So we got 6. When would the distribution of means be normally distributed? These all correct responses. So they're going to be in different order for all of us. So I'll just read where mine are at. Data are drawn from a population that is normally distributed and the sample size is small. That'll be normal.
Yeah, because it's still from normally distributed.
Mm-hmm. Data are drawn from a population that is normally distributed and the sample size is large.
That one would also be because it's still normally distributed.
Data are drawn from a population that is right skewed and the sample size is small. That is not checked.
That's not.
Yeah.
Data are drawn from a population that is right skewed and the sample size is large. That will be checked.
Say that's true based on it.
We approximately normal.
Approximate.
Yeah.
Depends on how large of the size, I guess.
Yeah.
All right, so that was easy. 7. Which of the following gives the best explanation of the central limit theorem?
So central limit theorem, as the sample size n increases and becomes large, the distribution of sample means becomes the approximate normal, which they sounds like that.
Here it looks like if the sample size is large, the shape of the sampling distribution of the sample, mean x or whatever, will be approximately normal.
That
Yeah.
sounds, yeah.
Yeah.
Sorry, I just read the definition, so I'm looking at all of them, and I think that sounds right.
Yeah, that does.
All right. For 8, it says let x be a random variable with population mean of 10 and a standard deviation of 6. Suppose a sample of size 36 is drawn from this population. N equals 36. Okay. What is the mean of distribution of sample means?
I feel like this is a trick.
Is it 1?
Oh, isn't that?
The mean of the, because I wrote this down because it was so confusing. Mean of the means is the population means, which is just the mean. So isn't it?
Yeah.
That one's 10.
So it's
Yeah.
10. Yeah, 10.
Okay. What is the standard deviation of the distribution of sample mean?
So that's the
Is that 1?
standard deviation divided by the square root of.
Yes. Of n, right?
Yeah.
So
So 6. Right, so 6 divided by the square root of 36.
Yeah. And I got 1.
yeah, because square root of 36 is 6.
I got 1.
Over 6 is 1.
So that's number 9.
Wait, when it says to 3 decimal places, are we supposed to put 1.000?
No, I don't think so.
Well, because
I mean, I guess we could.
I just find that confusing that she would put that in parentheses when it ends up being a whole number.
wait,
Yeah.
do you have that for number 8? I only have that on number 9.
My number 9, yeah, that's one we just did though, right? Because
Yeah.
mean
This is
of
a
the distribution.
confusing question, and this is
10.
something that she needs to look at, or the school needs to look at, because normally it'll say, for the questions 8 and 9, let x be a random variable with population mean, yada, 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 right? Here it just kind of says that for number 8, but then for number 9 it just asks a question, what is the standard deviation of the distribution of sample means? 3 decimal places. That
Oh, yeah.
very
That's,
But just one's good then. That's what you guys are doing.
yeah, I just put
what I'm
one.
going to do.
Yeah.
I mean, it is a very vague question.
That's cool. I just thought it was awkward that they would have that 3 decimal places on that one.
Yeah.
Keep going.
I'm just assuming that she does it on everything, whether or not it's needed.
Yeah.
Sounds good.
Okay. 10. Regardless of the distribution of the population, if the sample size is large and is greater than 30, what would the shape or the distribution of the sample mean? What would be the shape of the distribution of the sample? Blech.
I would say normal because then it's greater than 30.
Yeah, that's what I was gonna say. Cause yeah, that's what I was gonna say. So.
Yeah. Okay, so normal. 11. What theorem would justify your response to question 10? The central limit theorem?
Yes, that's the one where the more as the sample size increases, yeah, the more
It
approximate.
becomes approximately normal, and the other one is all about accuracy.
Yeah.
Yes.
Okay, wait. So sorry. What did you guys get for number 9?
Number
Yeah.
9 is 1.
So 6 over the square root of 36, if we're using the data from the previous one, which we are assuming we're supposed to. So that would be 6 over 6, which is
1. Okay, so then. Okay, then. Just kidding. I got it.
So
I
we
was
put in.
behind the question.
And did you get 10 for 8,
Yeah.
Ashley?
Yeah, I got it. I was behind. We're fine. You guys, I'm really like mentally dead tonight, so.
You're doing great.
Still managing speech for being dead. It's good.
Okay, so we're submitting this then?
Are we doing central limit theorem for 11?
Yeah.
Central limit
Because
theorem.
that one is approximately normal versus the law of large numbers. And my notes is all about accuracy.
Right. Right.
So,
Okay.
Let's give her a shot.
yay, 100. I really needed that, guys. Thanks.
Hey.
Good work, everyone.
Okay,
So
I'm
that,
going to go and end this broadcast and post it really quick and then invite you to another one. So,
Awesome.
you guys in a minute.